All right. So it's a syntactic sugar around the prover, because as Jan and I have been continuing to work on trying to prove things with the prover that we have, the proofs, they got so long, and debugging them got so tedious. And also we now see patterns that are emerging in what kind of calls to the API of the prover we are making. And the prover, I mean, well, of course, the SMT basis of the prover is Z3. But there is stuff that Z3 cannot prove on its own. So let's say we have a horn solver on top of Z3, and on top of the horn solver we have other things that manually writing this, instantiating for all new blah 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 blah, and it got the clauses themselves that we were writing. They were like, okay, well, here's a 20 pages of small talk to instantiate all of the things and then pass them to the solver to solve the horn clause. So I said, wouldn't it be nice to have some kind of notation that would be closer to the normal mathematical notation? And I was, for years now, I was put off by, well, it's not clear what such a notation would look like, and I made a number of false starts on that way. And then I thought, all of this, if you look at all of these things, this one, and then this with horn predicates, they are one or another kind of quantification, and or more generally, they're bound variables. And I thought, well, if I actually put more syntax into Smalltalk, so I extend the Smalltalk syntax, well, I'm not sure if I can make something nice that will still be the LL1 in terms of like the BNF category of it. And adding more is not something that on philosophical grounds seems or feels right. So I said, actually, I can shrink the definition of the Smalltalk syntax and make it more general, so it covers all the cases. So when we write in Smalltalk, I'm not sure if you are looking at my screen that I will be typing.
We are.
So when you write something like this, it actually, well, we would say, well, this is this is a lambda abstraction, but actually, if you think about it, what this column is telling me, well, it's a lambda abstraction, but more generally, it's a bound variable, and a particular kind of bound variable or dummy variable, like in an integration, integral over some definite things, blah, 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 dx, right? So what it's telling me is dx is just, I'm looking at the preterm, but what I'm trying to actually say is, well, it's the equivalence class modulo alpha conversion, because dx or dy or dz, who cares, right? So in terms of the scanner, all that this says two things: that okay, this is a bound variable, and the kind of binding is it's a lambda abstraction. So I said, well, I can write things like for all x, or there exists x, or star x, for Horn abstraction. And I can actually reduce the size, the size of the grammar that the scanner knows about and the parser knows about. So I just say, okay, well, there's a bunch of characters that are special at when you encounter them. That's the beginning of some kind of bound variable, and then that's it. Everything else is outside and is user supplied. So you give the scanner a dictionary of things that, okay, column is how you parse a normal lambda block. Okay, the for all thing is something that starts a universally quantified block. There exists starts at and the star a Horn block and so on. And then there are just classes. And the way how you instantiate is exactly the same what the normal, for example, in Faro, what the Opal compiler does, right? So you just, okay, well, there's a bunch of code. Let me show you what I do. And then we'll save this. And this is, so I have, instead of normal block argument node, I have a general one that is bound argument node, and I have this normal lambda thing, and just the visitors know how to visit that. This is the normal block, right? And then I extend, say, the translator. You can visit the normal thing, it's just visit block node, so that he gets from actually even from somewhere outside. No, it's because no, sorry. So this is, no, I want the whole thing. Where is my visiting? So yeah, that's the normal stuff, right? The visit block node and whatever. And the interesting one is it pushes, right? It push closure, blah 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 blah. So what I do here in visit, for example, quantification node, it's exactly like the normal thing. It's just, we push the arguments, we push the sort of the argument, and because and then we push the block body itself, and the sort, and then the refinement is because I'm gonna show you again what it looks like. For example, a simple first order quantification. Well, here, right, as soon as the scanner sees this and gives it a class that takes care of parsing the rest of the argument declaration, oh, it's not just for all x, but you can do things like for all x, and then I say from what universe I take them, right? And this is nothing like special syntax. It's just in the declaration of the test itself, they're just instance variables, and when I am setting up the test, I just compute them. But there are like these ones, they can be anything, right? I can say bit vector of size 32, and my X will be these bit vectors, or I can, uninterpreted sort, or product of many different sorts, or algebraic data, whatever, right? Like whatever I can, it's in there. So that and then I am piggybacking just on Smalltalk notation or the normal Smalltalk machinery for copying temps and creating nested blocks and creating blocks that are actual closures, closing over things, because this one is the trivial one. But the interesting point, and this is where it gets or starts getting interesting, is that you can have dependent things, right? So now this inner block it signifies that actually it is a dependent type, right? So it's all of integers y that are larger than x, right? And you don't really need to invent anything new, because you just the temp copying from the outer closure to the inner closure, and managing all of that is already done for you by the normal Smalltalk compiler, because they are not specific to lambda blocks. That what I realized and what motivated me to actually try implementing this in an actual thorough system is the realization that all of that is common and works exactly the same for any kind of bound variable. And this is a dependent kind of dependent thing, and this is the first order kind. So you can go higher. You can say, okay, can I can I do horn queries? Like this says, okay, there is, or I can find a predicate kappa 0 over integers such that for all x satisfying this predicate, x greater than 10. And this I need for synthesizing the weakest preconditions for Floyd-Hoare logic, because, well, this one actually, if you look at what it will do, you would think, well, okay, kappa 0 is x greater than 0, right? But no, that doesn't do it. And the way how you discover that, or get an intuition why this is not sufficient, is here, right? Like, can I have a kappa 0 that if x satisfies him, then x is both greater than 100 and less than 0. And you would say this is not safe, but of course it is, because kappa 0 could be absurd, right? And from absurd you can, if x satisfies absurd, then of course he satisfies also this, and the solver obviously finds this. So
Boris,
Yes.
A question. I mean, more clarification on the meaning of for all x in Z, for instance.
Yes.
I get that what you said about the colon, etc., but it's not clear to me whether this means that you are in that statement creating, in this case, an integer sort for x. Are you? I don't get whether x becomes after for all x in Z, whether it becomes an integer sort or not, or what. I think that Boris' connection was lost. Let's wait until he resumes.
Okay, good. Right. So the question was what this is.
Yes, what the meaning of for all x in Z. I guess this is saying that x is an integer sort, but I'm not sure.
Well, no. Zahlen is an integer sort, but x is any element of the integer sort.
Yeah. Okay.
So it's a dummy variable, just as when you create something like this, right? So when you go that, right, you don't create an x which is an object, a class or anything, right? Well, in this case, x is actually any term, right?
Sorry,
but it's just a variable. It's a variable declaration. The same way here, it's a variable declaration that x, and it has in the declaration itself, it has two things. It has a sort, which we pass in here, and it has a refinement, which we pass in here because it's, you know, the domain may be a subset of the Z3 sort.
Okay, Boris, sorry, we have Luciano trying to enter the meeting, and for some reason it's not working for him. Give me a second.
Okay, right. So right. So the domain over which x is ranging can be a smaller, you know, can be a subset of the whole. Oh, I guess we have Luciano now. Perfect.
Yes, we do.
Okay, good. Maybe shall we very quickly summarize the content of what we covered for Luciano?
Okay.
So I was talking about this this idea that in Smalltalk we write things like that, if you can see what I'm sharing on the screen, but there is nothing special about this one. We're lumping two different ideas. Is that this is a lambda abstraction, but lambda abstraction is a particular kind of any bound variable. So just by saying, well, this token can be generalized. So instead of hard coding this in the scanner and then in the parser, I just say, okay, well, here is a bunch of characters that can serve as, you know, that start a declaration of a bound variable, and then we just give a dictionary that say, okay, well, this guy, the column is lambda abstraction, and this for all symbol starts declaration for a universally quantified X, and star is a Horn clause, or Horn variable in a Horn clause rather, and so on, and it's that way the Smalltalk syntax, instead of being bigger, actually shrinks a little bit, because now the parser and the scanner don't have hard-coded any hard-coded information about what this is, and it's also more general, so you can write things like that. And in this case, so what I was showing is that, you know, this star kappa exists a predicate over integers such that if X satisfies the predicate, then this, and the Horn solver synthesizes absurd for kappa in this case, and obviously this is satisfiable, but we cannot really write exists, because exists is something that is, you know, you quantify over the individuals, and this is not an individual. This is a so we are talking about existential, but of a second degree logic, right, or second order existential, right.
So Boris,
Yes.
the X is no longer an argument of the block. It's a generic variable of the sort you define.
It is an
Can you evaluate for a particular X here? I mean, is still
no, because it's not a lambda abstraction. No, the reason why you can do value on a lambda block is because it's a function.
Yeah.
And there is this in the algebra, it has this evaluate, right? So it acts on something. But if you forget about the particular mathematical nature of that block thing, right? If you forget that it is a function, like not everything you can apply to things. So this particular one you cannot apply to an integer, because it can be safe or unsafe, or it's either true or not true, right? Or in a three-valued logic, it can be, you know, true, false, or unknown, or, you know, undecidable. But it's more of a it's a judgment, right? But it's a judgment of a particular kind, because it's a dependent. What's interesting about this is that it's a dependent judgment. Like, for example, we saw this guy here, right? Like this judgment, it closes over X, which is defined outside, and that gives it the power, because now you have, well, it's pretty much full dependent types here, what you have, right? Because you can say you can say things here, you know, it doesn't have to be a simple arithmetical expression like this. It can have branching, like if true, if false, and so on. And we use this to actually prove things, like, well, we have in Sprite, that is a toy research language that the Liquid guys are using for experimenting with their stuff. So I started from just following what they were doing, But then I said, okay, well, with this notation, if I have just, you know, block-like things, I don't need to do what they're doing, and I can just compile these things. How can this? I can just I can just parse this, and it becomes just those blocks. So for example, this guy, right? So it's an if then else. So abs takes an int and gives an int, but an unknown subset of int, right? So abs is, I look at whether it is non-negative, and if it is, then I return this. Otherwise, I return the opposite. And then I want to synthesize the contract for this, right? This contract is an unknown, the post condition is unknown, and I synthesize it from an assert. So assert like, don't pay attention to this in that should be void. It's just, again, this was a little experiment. It takes a bool such, it takes a bool B such that B. So what does that mean? Such that B means such that B is true.
Mm-hmm.
So my domain is Booleans, but not the whole set of Booleans, but one particular subset, which is a true. So if I analyze statically the behavior of this main guy, the analyzer says, oh, okay is declared to be only true. So it would be a type checking error if okay could ever be not true. So it says, oh, so this y abs, or ya for y's absolute value, must be always non-negative. How did I get it? Oh, it's by calling abs on y. So this return value must be greater than 0. And then it analyzes the two branches. If pos is true, so if x is greater or equal than 0, then I get x, and it's satisfied because x is already greater than 0. Then if it's less than 0, then okay, then this guy is strictly greater than 0, and therefore it is greater or more than 0. And what it does is it uses this bidirectional synth check loop, in which this I can show you. It becomes if I did well, I had in Faro, it depends on where your focus is, right? So I'll step into this. So that, and then right. So first I do VCGen, that's the generate the verification conditions. So because this is more, this what I showed you is more than just Floyd-Hoare. So we have to get from this more general form to just normal Floyd-Hoare. And that, now I have a Floyd-Hoare form, which is, if I get into the solve, self is now a Horn query, and inside there I have a var, which it synthesized, right? It's just this K, it came up with some new name, right, for a unique ID. And it takes a product of Zahlen and Zahlen. And here's the constraint. I'll show you if I make it bigger. So this is the constraint. So it is two things, right? Well, one is it puts a number of stupid things, like this is just a true, and then this guy really doesn't say anything, because again, it takes things. Let me make this bigger so you can see. So this is the precondition, and then blah blah blah, and then we say, but this doesn't say anything. So really, the real one that we're interested in is this guy. Well, actually this, right? So that's pause and blah blah, and you can see that they can be rather big, and it's pretty much not, you know, not transparent. But if you simplify, I have a test that does exactly the same one, and it is in where was this? This guy, yes. So that is the simplest form that apps boils down to. This is again in the syntax of these liquid Haskell guys, but I have to get rid of all of this machinery completely, because now with this, you know, concise for all things, we can do very you know, in actual small talk without any kind of parsing of these things. And this is pretty much it. Actually, I do have this test in.
I do have a question about your new
Yes.
proposed syntax. So after the for all identifier, right?
Yes.
And the same with the star. Do you allow different domain-specific syntax for each identifier, or the same thing that you have? So here
You mean here?
Yeah, everything that is to the right of the X.
Yes.
Up to the,
yes.
up to the pipe. Yeah. Is that
yes.
domain-specific or?
Well, no. What this is right now in the experimental implementation, I'm not saying this is the way how it should be, right? But in this quick experiment, what happens is when the scanner sees this, it returns a token that begins a bound variable, right? But that token knows how the rest of the bound variable is parsed. So if you have :x, then that's just your normal small talk thing, right? And then the parser knows, okay, well, there is an identifier, and then everything else is either a vertical bar, and then there is the body of the block, or another colon. So if you have several arguments. But this guy, he knows that, oh, there is an ID, and then there is possibly the sort, like for all integers, and maybe there is also a pre-qualifier, right? If the domain is a subset of integers. So in this case, it's for all integer x such that kappa 0 is satisfied.
Okay,
But
so
in this case, for
a
the
little grammar for that. Basically, for all, there is a small grammar that everything that you can.
there
put
is a
in the
tiny
right.
grammar. Yes,
Yes.
yes.
So and I have a follow-up question. So if we go to another nested example with nested blocks, right? That you have two for all. Do you have one of those?
What?
So
Say
in
it
this
again.
case, you
A
have
method block.
no. In this case, you have nested. You have a star and for all. Do you have one with for all and for all?
Oh yes, that's the this dependent one.
Okay, so it, you might not. So if you don't do it dependent, you might not need to create two blocks, right? You might use a single block, right? Is that fair? Can you say for all x, blah blah blah,
And also for all blah blah
for all
blah.
y?
Right.
Yeah.
It's not it's not actually implemented right now for the for all and exist and blah blah blah. But obviously it can be done. It's just, I mean, it's just bug fixing, right? But for I'll show you another one. I'll show you this or this, right? These are actually nested nested horn variables.
Yeah. But
And this is simply oh, I need to tell you something that for a very long time in all of my Faro images, and this is in pre-Smalltalks, I call the package. It's also part of machine arithmetic, and I kind of that blocks in this Faro, I guess, or in this whatever. They are automatically curried and uncurried. So if you have if you have a 2-argument block and you say value : 1, instead of error wrong number of arguments, you automatically get so something like
yeah, I know. Yeah, okay, that's nice. That's nice,
right.
actually.
So
But
this is the same, and it's completely like if you give it if you give it this, or when you give it this, it's not that the syntax is special. It's because of the auto currying.
Okay.
yeah, one last thing is that you probably might be able to mix with column too, right?
I think so.
That
I
would be
think
interesting.
so.
Like say you mix with a single column. That the meaning of that could be a block that when you
Just
do
nested,
value
yeah.
gives you something that you can give it to the prover.
Yeah. Yeah. Oh yeah. The thing is, this is second order logic here, right? So this is first order because you quantify over individuals, right? So you quantify over all integers or your bit vectors or arrays or whatever Z3 can do. But this is a second order because you here existentially quantify over predicates, right? So can I synthesize, and it has to be constructive too. So can I not only prove that there exists one, but can I actually synthesize a predicate that will make this whole thing true? But that is only second order. It will get better. It's just I only started experimenting with this, and I wanted to show you guys because previously I heard criticisms about extending Smalltalk syntax that, oh, this is a bad thing, and whatever, people dislike the whole idea of even trying anything like this. So that's why, I want to here criticism that, well, maybe this is stupid and not worth going forward or something. But the path forward from this is that, well, this is a judgment, right? And it could even, you know, I could give an argument to this whole method and then use this somewhere inside these expressions. So now it's a judgment that is a closure over arguments, or may depend on current value of globals or instance variables or whatever. And these are also objects, and I can pass them around, and I can take, you know, return something like this from a method and then pass it around and then use it inside here. So, and these things, I can do it in a cycle. So I can have, you know, first order, second order, third order logic, and so on. And it's the nestedness might be unbounded. And in the solver, I have machinery for proving inductive things. You know, if it's for nth order of logic, I can prove things about n plus first and so on. But I haven't, you know, I'm just dipping my toes in that now I have syntactic sugar for this syntactic sugar, and that creates those instances of these judgments. And now what else I can do with them is, well, I'm thinking of continuing the main, you know, the main line of this program of research, which is the solver can actually has as much expressive power as Lean, and it's the API is actually very, very similar. So to have a Lean kernel is well, it's very concrete. You know, I know exactly what steps I need to do. I just have to, you know, finish doing them and then, you know, remove all the bugs. And then after we have that, then we have access to the whole library that Kevin Buzard is doing. And then we have access to pretty much all of mathematics from this. But that is, you know, it's just that I think I got kind of, well, not really stuck, but it was very unpleasant to instantiate all of these judgment methods manually. So something like this would be, I don't know, 10 pages of small talk.
So I have a last question, actually.
Yes.
So when I read this new syntax that you are proposing, right, my a priori will be to think of it a bit of a block closure. With this, I mean that if you are using something that was defined outside, like Blackboard C in here, right? I will expect that if you change that, and I have the object that the thing return, that object reflect that change, right? Because it captures the value, right? So I mean, yeah.
Yes.
The behavior of a block closure.
Yes. It is
that...
the only thing it is a block closure in all respects other than what kind of quantification it is, right? Instead of a lambda capture, it's a for all capture, but it's a capture, right? Or integral from 0 to 1 f of x dx, that is, you know, it captures x, and in that sense it behaves exactly so it's an instrument for understanding, you know, in a block closure what really belongs in capturing and what belongs in the particular lambda kind of capturing, right? Because if you just say, oh, the only way, the only thing I can capture is a lambda capture, right? Like normal block, then these two things, they collide and they mix in your brain, and you don't, you don't realize, or you don't explicitly understand that, oh, well, some of them are actually, there are two concepts.
Yeah, I got that. So, but my question is, what happens if I get an instance of this object, right?
Yes.
And then I can see, right? In the original object that created.
You change what's inside. Yeah, well, it's just like, yeah, it's a full closure.
Like a block closure, right?
It's a full block closure. That's
okay.
That
was my question. That's great.
Yeah.
Okay, thank you.
Yeah, and it's the key to its expressiveness, because that's the whole, like doing this, this dependent things, right? Like X might, but you don't necessarily do, right? Like you can add A and say greater than A, right? Well, of course, it's not gonna actually run here because it's a test, right? But like if it were not a test but a method, right? And you say, okay, well, I wanna just return it, right? I can do that too, right? Well, now I have a method that returns a
We lost Boris again, once again.
Yes. Boris, if you look into the chat, do you see some content?
Chat. No, I don't.
Okay, I was talking about some idea that we had about the general literals, which means that you write a class name and then in parentheses some content, whatever it is. And during the compilation, it would take the string inside those parentheses and put to the class, or send it as send some special message to that class, and it will return an object that will be put as a literal to the method, which is useful for many other things like embedded JSON or formatting, some special formatting things and so on. And maybe it could be used even for your case. I'm not sure, something like this, that you have class proof.
Right.
I'm not sure if you need the block that is inside, that I pass it here with the comma operator as a literal, but yeah.
Right. Because you cannot really because you know that what is in parentheses is not a message, because, well, syntactically, right? And each class knows his own syntax, right?
Yes. And because it's in parentheses, normally you do not have something which has only right parentheses.
Default.
So that's alternative solution to your problem, maybe. Which doesn't simplify smalltalk syntax, but extends it. But
I don't think it's an alternative.
I think is not so much of. I mean, there are two sides to it, right? So one idea here is really making a syntax that makes these quantification things more, nice to write, and in a way that composes and you can nest them, and then this dependent nature of them you can nicely that's that was the starting motivation. But when I started actually thinking about it, I understood the second part of it, and this is what I said about that colon X here, that really I am simplifying the notation for blocks. So you know, you would then, if we followed this, what you wrote in the chat now, now I see it. What you wrote in the chat, then you would have to say a block closure, parentheses, and then this is again becomes special, right? But that's the nestedness there is the other way around, right? It's not that the block notation is specific to block closures. No. There is the block notation with arguments, vertical bar, body, that is specific to bound variables. But bound variables can be different kinds. You can go colon, you can go for all, you can go star, you can go, maybe somebody goes whatever, right? In integral, right? You have integration variables. Or in mathematics, you have, I don't know, many different kinds of bound variables. So here, the idea is that the idea of boundedness is an idea of its own, and a lot of the machinery of parsing blocks and you know, copying temps and all that is really not specific to lambda blocks. They are very general. So decoupling the lambda from capturing is what's really interesting here, I think. Or maybe it's not interesting at all. I don't know. This is why I called this meeting, right? Because a number of years, for a number of years, I've been.
Oh, again.
Once again.
So I was wondering how this relates to the first class variables that we have in Faro. So in Faro, every variable in the system is described by one instance of a subclass of variable. So that means there is the concept of instance variable, and then there is one instance for point X, and every AST node that reads X and point knows that it is this variable, and this then has a meta API so that you can say, oh, read this variable in that object. And the same is true for temporaries, and we could hide a lot of the complexity of the escaping variables and code generation and stuff behind that. So that means now the debugger, for example, it just gets the variable, and then it gives the context, and they get the value of that variable. So it's very, very nice. And the question is, could we, how is that related to your variables? Because in some way, your whole block is a variable description. But on the other hand, inside there are variables like the X that you reference that are internal variables in some way in addition. Or,
yeah, but they're not different from what is in normal blocks. They're not different at all.
But
right?
could it make sense to make them different so that they could, for example, know that they are a dependent variable of another one, so that you have a meta API on that level?
But it's the same in normal blocks, right? Like
okay.
When you are a dependent variable, all you are is you're just simply closing over that variable.
Yeah.
Like,
but the question is,
you already have, like, the only thing is that the only thing how for all X is different from colon X is that it doesn't create bytecodes for apply.
Yeah, but I wonder if having an explicit meta object for these variables could be interesting. I mean, of course, it would not be needed for just executing it, but if that would be an interesting thing to have. So to kind of take the same ideas that we have in Faro, that every variable is described by a meta object, which in your case then would be a normal temp variable, because it has the features that you need, like closing over, but you could maybe have a subclass of this kind of temp that then knows that it's actually a quantified variable and has a bit more meta information of itself.
Oh, right. So instead of going from a parse node for the argument, and it's a special kind, that knows that I have a domain, which is
Yeah,
a
exactly.
sort and a refinement. So the variable in its meta information would have that.
Yeah.
That's
was-
yeah, that's one possibility.
I'm not sure for what one would need that, but it feels like it could be an interesting, fun experiment to have.
Yeah.
I mean, we for example, for temporary variables, we only use them in the debugger
Mhm.
and for compiling. And we don't use the feature that we can make subclasses of temporary variables to make our own kinds of subclasses at all.
Mhm.
But it sometimes, it feels interesting to think in this case of them as subclasses of the standard concept of temporary variables.
Yeah.
It's nice. I like all these notions of syntax that opens up, that is open. It's
Mhm.
always very interesting. So because it allows, and I think it's actually very in the spirit of Smalltalk. So and in a way it goes back to Smalltalk 72, of course, to have
Right.
Yeah.
Right. Like if you've ever followed my, this things about Smalltalk versus Smalltalk 80, that Smalltalk 80 is in a way not a Smalltalk because it's so frozen and
Yeah,
everything.
exactly.
It has ossified and okay, here's the rule.
Yeah.
And
and
you stop expressing ideas. You start expressing like, okay, well, not not, but how do you implement things on a particular sequential machine of the 70s and 80s, and it's just not that interesting, and it's not what Smalltalk is about.
Exactly. I mean, that was what I maybe misunderstood about Squeak back then, that this would be not seen as a static thing where you have to be 100% backward compatible at any cost, and where even thinking of changing is somehow heresy because you are kind of criticizing with that someone, which is not true. You just take the good ideas and continue. So yeah, so as such, I really like the direction.
Well, thanks. That's reassuring that people at least are not saying no, you shouldn't be experimenting with this is a waste of time, and
no, very interesting.
Another aspect of this syntax is a little bit outside of your intent, Boris, but relates to something I did when playing with the C3 library that could be applied to the for all symbol, is to have prefixed unary messages. So I implemented those in B Smalltalk for and used for negating propositions, because you want to put the neg symbol before the proposition, so you have not P instead of P negated, which is more closer to the mathematical expression or way of expressing this. So for the for all symbol, this could be for all x in Z, you should put x in C in parentheses, and then for all becomes a prefix unary message that is a sort of assert that X belongs to Z.
Yeah, I thought about that, but then what is X? What defines X, right? Because at that point, X is not a declared, like who declares X?
It's not for the declaration, it's an assertion. It's different. It's for another part of, it's for the body, not for the.
Okay. It's, yeah. Oh, yeah, of course. Yeah, because X belongs in something. It's a judgment.
It's a proposition.
It's a proposition.
So if you put if you send the message for all and you write it as a prefix, you are asserting that X belongs to that sort.
Yeah. Yeah. Oh, yeah. 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 I think it's an iterative process that I've got enough of the prover, right? So that it's not just a binding to the Z3, but actually can do a lot more and a lot more abstract things. And then I say, oh, okay, well, actually using that API is now very, very difficult because the proofs are very long. Now I need syntactic sugar. Now that we have this much syntactic sugar, now what I want to do next is go back to the prover and make it even more abstract on top. And then when we have those abstractions, then we will see, oh, maybe we can think about syntax again and make a syntactic sugar for those higher abstractions.
Yeah. Another aspect related to this is that I think is worth discussing is about how we type these Unicode symbols. So the way I do is probably the same as you do, is I use LaTeX notation, like backslash.
Oh, yeah, yeah, it's tragic because I just copy paste them, or I start with a method that has similar thing and then I modify and save it under a different name. But right now, like inside Faro, I cannot type that.
Okay, but my suggestion,
bad.
because this is what I implemented in B and Luciano also implemented in Quiz, is you write, for instance, the belongs symbol, this epsilon thing, you backslash in space, and then it's automatically converted into this Unicode symbol.
Yes.
It's very handy.
Sorry, guys, I have to leave. So, bye.
Okay.
Okay. See you.
Well, all this typing business and other things, that's as we discussed before, that's part of my objections against these kind of things, because it's easy to get the parser done, but in order to be able to work with it, there is this tooling issue. So yeah, if this has to fly, someone has to take care about this tooling. That's the thing. And my objection usually comes from the fact that people stop at fixing the parser and don't care about fixing the tools.
Oh yes.
So it's not only about how to type them.
That's a much bigger conversation that is more about,
I know,
what is worth doing, or what is worth spending time on. And it's about, well, we have a programming system that is so easy to program that we're prone to inverse vandalism, and we have so much code, and for very simple things, my criticism of Faro has always been like, okay, I'm trying to do something, and in order to be able to do it, okay, now I have to read this and this and this and this, and then spend many days trying to understand what the code is doing, and it's gonna get changed next year again, but then there is other kind of thing that you at first sight maybe you don't like, if you're not haven't been familiar with it from previous decades, maybe you don't recognize it, and it looks like yet another piece of inverse vandalism that somebody wants you to read. But here we're talking about things that have been there for, well, actually before computers were invented, right? All these algorithms for these things, all of the theory of how to prove these things, and then if we have a program, you know, how we approximate functions by algorithms and all that. That was, you know, that's the 20s and 30s, and actually before the invention of the computer by Turing. And that is the stuff that is actually, you know, if anything is worth spending time on, this is more worth spending time on than you know, many other things. So it's not just yet another thing. I mean, and this is why I call this meeting whether the notation itself is at all interesting, and like whether we should be pursuing this notational or syntactic thing, because the objects that it represents, those are fundamental to computing, and they are these algorithms that we're looking at. They will outlive many other things that we are trying to write. So that is, to me, that is a decided question, right? Now, whether trying to extend the syntax is, well, there is this Iverson idea that, you know, if your alphabet is so limited, then your language is limited, and if your language is limited and doesn't compose and doesn't let you express interesting things, well, then you're wasting programming effort. So the whole, you know, APL thing, and it's quite a radical approach. Without going that, you know, can we do something that will gain us in a lot of proportion by changing syntax or by experimenting with syntax? That is something that I'm not sure about, right? What I am sure about is the actual objects that I am modeling with this, you know, the stuff that this for all notation is just a syntactic sugar for. Well, those are fundamental, that for sure. Now, do we want to really get into, because in Faro, like while I was showing to you on the shared screen, it never happened, but a lot of times when you start experimenting with these things in Faro, there are so many tools that think that everything is, you know, well, it's not only in Faro, is generally what I call the liveness versus the universal liveness, right? And you cannot really experiment with many things because the system assumes that everything works, right? So if you start changing the VM, you're dead. If you start changing the fundamental things like, you know, compiled method, you're dead because you no longer have a running system. And with this, I start changing the parser, but a lot of things in Calypso assume certain things about things. And as soon as you start changing them, you get in your face, you know, dozens of debuggers suddenly pop up. Oh, that guy doesn't understand this. Oh, that guy doesn't understand this. Oh, this failed, this failed, this failed. And, you know, what to do about that, I don't know. Or even like, are those syntax changes, are they interesting enough, you know, to go down that rabbit hole? And then it's what Jan said about, well, now we have to care about extending the tooling and, you know, well, scopes. We already have the microscopes to look at the objects, because the objects, well, they are these fundamentally interesting objects that we have that we need to have microscopes for them. So that's a settled question. Now, syntax? I don't know.
Okay, guys, I think we can close here unless anyone has anything to add. I think this could be a good time to stop the recording. Is that okay?
Yes.